Welcome to Easy Learning tutorial on YouTube. You are welcome. We appreciate you as a watcher. What we have for you today is a differentiation of algebra function. Differentiation of algebra function. We have done a fixed principle differentiation, but now we are entering into general differentiation, which we call differentiation of algebra function. And what do we mean by differentiation? Differentiation is simply mean destruction. You destroy while you are doing what? Differentiation. After you destroy, we now come back to restoration, which we call integration. So know it now that differentiation is destroying, while integration is the restoring back what you have differentiated. So restoration is integration, while differentiation is destroying. So let us look at the format of differentiation. Number one format said if y is equals to x raised to power n, meaning that y is a function of x, yn is the power of x, and the x is a variable, and y depends on x. And we can simply write this. You may ask to find dy dx. Find dy dx means what? Change in y over change in x in respect to x. I want to say that dy dx is equals to dx raised to power n, because my y is equals to this. If I remove this y, I put this x raised to power n all over dx, and my answer should be n times x n minus 1. That's the format. This is what we call the format. My answer will be n times the what? The base. Then subtract 1 from the power. For example, if I have y is equals to x raised to power 3, then dy dx is equals to dx raised to power 3 all over dx, and the answer is 3 times x raised to power 3 minus 1, which give me my 3x raised to power 2. That means I have differentiated this, meaning that my dy dx is equals to 3x raised to power 2. And this implies that dy is equals to 3x raised to power 2 dx. Then what this means? Cross multiplication. That's what I did. If you have this over 1, you do cross multiplication. This over 1, cross multiplication, you will have this. And that's how I get this. And what this is telling me, is telling me that this man had been differentiated. This here is a symbol that this particular value have been what? Destroyed. Meaning that have been what? Differentiated. Not its original value. This dx is telling me that this value is not of its original value. That is, they are being destroyed to this point. Then let us look at another example over here. Let us look at another example. If y is equals to x raised to power minus 2, we say that dy dx is equals to dx raised to power minus 2 all over dx, and the answer should be minus 2 times x raised to power minus 2 minus 1. And my answer will be minus 2x raised to power minus 3. How did I get minus 3? Minus 2 minus 1 means I'm owing 2. And I'm owing another person 1. Total of what I'm owing is what? 3. I'm owing 2. And I'm owing another person 1. Total of what I'm owing is 3. And that 3 will be minus Minus means what I'm owing. And that gave me the answer of this what? Differentiation. Then I can also write this answer as this way. dy dx is equals to 3 minus 2x raised to the power minus 3 all over 1. Cross multiplication will give me that my dy is equals to what? Is equals to minus 2x raised to the power minus 3 dx. And I said before, this dx is telling me that this man had been what? Differentiated. That this man had been what? Differentiated. Also, let us look at this. Another example, if y is equals to root x, we now say find what? Find dy dx, means we should differentiate. And my dy dx simply mean before I can differentiate this man, that is inside the root, I'll first bring him out of the root. Just like somebody that is in a cell, in a prison. For you to attend to the person, you have to bring him out of the word prison. So for me to attend to this man, to be able to capture this man, I have to bring him out of this root. And how am I going to do that? I want to say that this function is something as y equals to x raised to the power 1 over 2. That's the indices. Indices, the law of indices said that when you have root of x is something as what? A raised to the power 1 over 2. How did I get that? If I have this cube root of a, this simply means a raised to the power 1 over 3. So if I have fourth root of a, this means that what? A raised to the power 1 over 3, 1 over 4. So how did I get this? By squaring both sides. If I say that my y is equals to a raised to the power root of a, if I square both sides, this simply means squaring both sides, I will have y squared is equals to a. Y squared is equals to what? A, if I square both sides. What does it mean? Squaring both sides, for clarification, I'll have y all squared and the root a all what? Squared. And when you square the roots, what it will leave you is what is inside the root. Then to clear this man, these two, I have to what? Power this by 1 over 2 and this by what? 1 over 2, and I will have that my y is equals to a raised to the power 1 over 2. That means that if I have this, I can convert it to this. So note it now. Let's move. Then now, if I want to remove this from the root, I will have this. Then I want to say dy dx is equals to d x raised to the power 1 over 2 all over what? Dx. You get me? Then this is equals to 1 over 2 times x raised to the power 1 over 2 minus 1. You get what I'm talking about? This now will give me equals to, watch here, this will give me equals to 1 over 2 x raised to the power minus 1 over 2. Somebody will say how? How do we get that? The shortcut, what do you do when I have x raised to the power 1 over 2 minus 1? Instead of me doing else here, what I did is by doing what? 2 times minus 1 will give me minus 1. This 2 times minus 1 will give me minus 1. 1 minus 2 will give me minus 1 over 2. I'm coming again. Shortcut. I'm trying to give you shortcut. This 2 times minus 1, it will give me what? Minus 1. Then 1 minus 2 will give me minus 1 over what? 2. Assuming we will have 2 minus 3, 2 over 3 minus 3. How do you do that? This 3 times 3, 9. My 2 minus 9 will give me what? 7 over 2, which is minus 7 over 2. I think you're getting what I'm talking about. Then assuming you have again maybe 2 over 5 minus 2. Simply what you would do, this times this will give me minus 5. Then this 2 minus 5 will give me minus 3 over what? 5. And when you do LCM, if you use LCM, you will still get back to this. I'm just showing you the shortcut of this. Then let's move. We move. Okay, then let's move. I say that this simply means this. I think you know how I get that. That means that my dy, my dx is equals to 1 over 2 x raised to the power minus 1 over 2. And that's my what? Answer over that. Then let us look at another example. Another example, if I have y equals to x raised to the power minus 3 over 2, and I'm asked, find dy, what? Dx. I would not say that my dy, dx. It simply means the x raised to the power minus 3 over 2 all over dx. And this simply means that minus 3 over 2 times x raised to the power minus 3 over 2 minus 1. And this will give me, as my final answer, based on what I told you, this will give me minus 3 all over 2 x all raised to the power minus this times this will give me minus 2. Minus 3 minus 2 will give me minus 5. I'm coming again. This times this will give me minus 2. That means 2 times minus 1 will give me minus 2. Minus 3 minus 2 means I'm owing 3, I'm owing another 2. Total of what I'm owing is minus what? 5. Over what? Over 2. It's give me over 2. You get me right? So let us click here to do more example for clarification. Then, if I have this, you remember that this also, that minus 3 over 2 x raised to the power minus 5 over 2 can be written as minus 3 over 2 times 1 all over x raised to the power 5 over 2. And this can be written as minus 3 all over 2 x raised to the power 5 all over 2. That means this can give us this. Then let us look at another example. If I have y equals to your roots, if I have y equals to x raised to the power minus 2 over 5. I cannot say that what? Find the words. Find the dy dx. I can simply say that my dy dx is equals to dx minus 2 over 5 all over dx. And this simply means minus 2 over 5 times x raised to the power minus 2 over 5 minus 1. And this will finally give me minus 2 over 5 x raised to the power minus 7 over 5. Minus 7 over 5. I get it. I said this 5 times minus 4 will give me minus 5. Minus 2 minus 5 will give me minus 7 over 5. And that gives me the answer. Let us look at the second format. Second format. We are dealing with the first format. Second format said, if y is equals to m n x raised to the power n. Then we are asked to find dy dx. We say that what dy dx is simply dm xn all over dx. What is m? Coefficients of x. What is m? Coefficients of x. What is n? The power of x. What is m? Coefficients of x. What is n? Power of x. Then, because of these coefficients of x is attached to x, and x, we are differentiating this y in respect to x. This can be n times m x raised to the power n minus 1. And that's the second format. That's the second format. And I'll say the example. If y is equals to 3 x raised to the power 4, comma, find dy dx. I can simply say that dy dx it simply means 4 times 3 x raised to the power 4 minus 1. And my answer will give me 12 x raised to the power 3. You remember? Then another example, if, that's my answer, if y is equals to 2 x raised to the power minus 1 over 2, we are asked to find dy dx. We can simply complete it over here. We can simply complete it over here by saying that my dy dx is equals to d of 2x raised to the power minus 1 over 2 all over dx. And that will give me 1 over 2 minus 1 over 2 times 2 x raised to the power minus 1 over 2 minus 1. And this will give me, half of this will give me minus x raised to the power minus 1 minus 3 over 2. I get 3 over 2. Minus 3 over 2. This time is minus 2. Minus 1 plus minus 2 give me minus 3 over 2. And half of 2 will give me 1. And that should be minus 1 times x will give me minus what? 1. Half of 2 will give me minus 1. That's minus half of 2 will give me minus 1. Minus 1 times x will give me minus x. And this give me minus 3 over 2. Then we have seen this. Let us look at this. If y is equals to 3x raised to the power 3 plus 4x raised to the power 2 plus 6x plus 2. We are asked to find dy dx. Right now, we have known how to differentiate. What do we mean by differentiate? What do we mean by differentiation? We have known what we mean by differentiation a little. Then we are asked to find dy dx. We cannot do that dy and dx simply mean d3 x raised to the power 3 plus 4 x raised to the power 2 plus 6 x plus 2 all over dx. And this simply means d3 x raised to the power 3 all over dx plus this plus, I'm bringing it down, d4 x raised to the power 2 all over dx plus d6x all over dx plus d2 all over dx. Okay, let us look at this. I'm differentiating this, man. It will give me 9. You remember what I did? This 3 times 3 give me 9 x. Then I subtract 1 from x. Power of x, it will give me what? 2. 3 times this will give me 9. I remove 1 from it. Then plus, coming over here, give me 8. 2 times 4, give me 8. Then I remove 1 from this. You give me x raised to the power 1. Plus. Are you get what I'm saying now? Or let me put it away. I will say 3 minus 1. Okay, let me continue. 2. I think you understood what I'm doing. This will be what? I'll have what? 1, which is 6x raised to the power 1 minus 1. And this will be plus. You remember, how did I get 1? Okay, let me start from gradually because I don't know how you are understanding this. I will have what? 3 times 3 x raised to the power 3 minus 1 for this. Plus, I will have 2 times 4 x raised to the power 2 minus 1. Plus, this will give me 1 times 6x raised to the power 1 minus 1. You remember that x, any value, anytime you write, is raised to the power 1. Then coming to over here, this man is a constant. Why did I call it constant? Because it has no x attached to it. As far as this man is not attached to x, because we are differentiating y in respect to x. What mean by dy dx mean that differentiate the function, this function called y. And what is the kingdom? X. This is the function, this kingdom. We say dy dx means differentiate this function in respect to what? X. It's only people that contain x in this function that will survive. Any term that does not contain x in this function is a constant. And when we differentiate it, it gives us 0. Get me right. When we have a function, y equals to this, is a function. That means y is a function of x. That's what this means. Y is a function of x. Then if we are asked to say, find dy dx, means that we are differentiating y in respect to x. That's the kingdom of y. We are differentiating it in respect to x. And any value that does not contain x in that function is what? Constant. And when we differentiate it, it will remain what? 0. So looking at this man contains x, this man contains x, this man contains x. y2 does not contain x, is a constant in this function. First, we have declared it in respect to x. So d2 dx will give me what? 0. You remember what I said? Why is it giving me 0? Because it's a constant. Because we are differentiating a function y in respect to x. Then if you don't contain x, that makes your name is what? 0 if we differentiate you. Looking at this function, I'm repeating again. Differentiating y in respect to x means that only the value that contains x that will survive that differentiation. Any other value that doesn't contain x will be what? Given to the what? 0 when we differentiate it. Then looking at this, I will have 9. As I said before, this give me 2. I'm settle this. Plus, this will give me 8. And I will have this over raised to the power 1. Then plus, this will give me what? 6x raised to the power 0. And then, you remember that anything raised to the power 1 is that x raised to the power 1 is x. And anything raised to the power 0 is 1. I will have 1 here. X raised to the power 0 is 1. Therefore, my answer will be 9x raised to the power 2 plus what? 8x plus what? 6. That means that my dy dx is equals to 9x squared plus 8x plus 6. And that implies, if you do cross multiplication, I'll have my dy is equals to 9x squared plus 8x plus 6 in bracket. I have my dx. What this is telling me, that this value has been what? Differentiated. Remember what I said earlier? This is my answer. You can write it this way. You can also write it this way. And that's the answer of what? Differentiating of this value. And when we do this, you remember what I said? This means that I differentiate this man once. That means this man has been destroyed once. Let us look at more example. Let's clean here and note more example on this. Again, if y is equals to 2x raised to the power minus 3 minus 4 x raised to power 2 x raised to power 1 over 2 then plus 6m plus 4. We are asked to find dy dx. That's what we are asked to find. What does this dy dx means? It means that we are differentiating this function y in respect to what? X. That means this kingdom called y, we are differentiating it. That only person that will survive this differentiation is the person that contains x. The only term that will survive this differentiation is only the term that contains x. If you then contain x, it means that you are going to be 0 when we differentiate you. That means you are constant. If any term that doesn't contain x here is a what? Constant. And when we differentiate it, it becomes what? 0. Then looking at it, I will not say that this dy dx is equal to what? d 2x raised to power minus 3 minus 4x raised to power 1 over 2 plus 6m plus 4 all over what? Dx. And I will say that what? d 2x in separates all over dx minus d 4x raised to power 1 over 2 all over dx plus d 6m all over dx plus d 4 all over dx. Right now, you remember what we are differentiating? We are differentiating this function in respect to what? X. Then this man here will give me minus 6. You know what I did? Minus 3 times this will give me minus 6x all raised to power minus 3 minus 1. Then minus this minus. Then I have 1 over 2 times what? 4x raised to power 1 over 2 minus 1. And I will have this plus. This man does not contain x. Look at it. What he contains is what? M. And what happened? It's now constant. Reason, he does not contain x. And since it's a constant, we differentiate it to give us 0. Plus, this man as well does not contain x. He is now become a constant because he doesn't have x with him. If we differentiate him, because we are differentiating in respect to x, this man will what? Give us what? 0. We move by saying that this will give me minus 6x minus what? 4. Remember, minus 3 minus 1 will give me minus 4. Then minus half of 4 will give me 2. That's 1 over 2 times 4 will give me what? 2. That means half of 4. This, you remember what I said about this will give me 1 minus 1 over 2. That means 2 times minus 1 will give me minus what? 2. 1 minus 2 will give me minus 1 over 2. Then this become my dy dx. That's my what? Answer of this differentiation. Another example, if we have x equals to 3t squared 3t raised to power 3 plus 4t raised to power minus 1 plus 5t plus 8. Where x is what? Distance. Is distance. Distance. And the t is what? Time. What does it mean? It means that distance is a function of time. I can write this as what? X of what? I'll write it as what? X is equals to a function of what? T, and is equals to 3t cubed plus 4t minus 1 plus 5t plus what? 8. What does this mean? That distance is a function of t and is equals to this. You remember what I did in the first lesson? That distance is a function of t and equals to what? This. Just like this one we did now. Look up here. Look at this one. We can write this as what? Y is a function of what? X and is equals to what? 2x raised to power minus 3 minus 4x raised to power 1 over 2 plus 6m plus what? 4. This statement can be written like this. And also it can be written like f of x. f of x is equals to 2x raised to the power minus 3 minus 4x raised to the power 1 over 2 plus 6m plus what 4. This are the same interpretation. Did I make myself clear? This are the same what interpretation. What did I say? This and this and this. If I see this, it's something like this. If I do this, it's something like this. If I see this, it's something like this. Note it now. It's the same interpretation. Coming to this, what we stated here. Look down here. Coming to this question. What it means that we are differentiating. They said find. The question said find what? dx over dt. What we are looking at is what? dx over dt. Can we do it over here? Let us look at it over here. Let's look over here. Let's claim here and do this. dx over dt. What does it mean? dx over dt means differentiate the distance in respect to t. And differentiating the distance in respect to t is what we call velocity. Velocity. Are you getting what I'm saying now? Velocity is what? Change in distance. Change in distance over change in what? Time. That's the definition of velocity in physics. Change in distance over change in what? Time. And that's dx dt means change in distance, change in what? Time. Just like when we say dy dx, what it means? Change in what? X. Change in y, which is change in y over change in x. And that gives me y2 minus y1 all over x2 minus x1. That what it means? Change in what? X. Change in y in respect to change in what? X. So now let us look at it. I'm differentiating it. And the value we are differentiating is what? X equals to 3t cubed plus 4t raised to the power minus 1 plus 5t plus 8. And when we differentiate this, we say dx dt. And that gives me d3t cubed plus 4t minus 1 plus 5t plus 8 all over dt. And this will give me d3t raised to the power 3 all over dt plus d4t raised to the power minus 1 all over dt plus d5t all over what? dt plus d8 all over what? dt. And look at this. We are differentiating this function in respect to what? T. Means that anybody that doesn't contain t in this function will be taken as a constant, and when we differentiate it, it becomes what? 0. Meaning that we are differentiating this function in respect to t. That we are differentiating x, this function x, in respect to t, in respect to time. If you don't have time with you, when we differentiate you, you become 0. That means we are a constant. Then that means 3 times this will give me 9. This will give me 9. T raised to the power 2. You know what I did? This time this give me 9 minus 1 will give me what? 2 plus. This will give me no more plus anymore here. Minus 1, which is plus minus 1 times 4 x times 4 t raised to the power minus 1 minus 1. You remember what I did here? Minus 1 times 4 t raised to the power minus 1 minus 1 plus. Look at my plus. This will give me 1 times 5 t raised to the power 1 minus 1. This is what it is. Then plus. Differentiating this, 8. It doesn't contain t. What does it mean? It's a constant. We differentiate it to give us 0. You know what I did here? 8 does not contain t. Differentiating it will give me what? 0. And I will have this equals to 9t raised to the power 2 minus, because plus minus will give me what? Minus 4t raised to the power minus 2. Then plus, give me what? 5t raised to the power 0. And my answer will now be 9t raised to the power 2 minus 4t raised to the power minus 2 plus 5. Anything raised to the power 0 is what? 1. And that give me 1 there. And 5 times 1 will give me what? 5. I will have this to be what? 9t squared minus what 4t all raised to the power minus 2 plus what 5. That makes my what dx dt is equals to it. And what does it mean? Velocity is equals to what? 9t squared minus 4t minus 2 plus what 5. That's my what velocity. Then if I differentiate this again, I will have acceleration. If I'm now asked to find dv over dt, what does it mean? I should differentiate this velocity in respect to t. And when I do that, it will give me what? Acceleration. Let us look at this place. When I say that what? My dv, my dt will be equals to, we are differentiating this velocity. You remember that what we have here is velocity, which we have as v, is given to me, which we have as our answer, 9t squared, and we have minus what, 4t raised to the power minus 2 plus what, 5. And I'm asked to find dv dt. That means dv d what, dt. And this is what we call second derive of this man. And this dv dt is same thing as what? dx2. Look at it. d2x all over dt squared. That means I'm differentiating this, means I'm differentiating this distance the second time. Hello? Get me right? This dv dt means I'm differentiating the distance, function distance, second time in respect to what? T. That's what this means. And that implies acceleration. And this will give me what? Acceleration.